Now in this lecture we will find the radius of the red semicircle. In the drawing we have triangle ABC. Triangle ABC is a right triangle. Angle ABC equals to 90 degrees, this angle, and side AB of triangle ABC equals to 3 units, line segment DC equals to 1 unit, and we want to find out the radius of this semicircle. It is inscribed by the triangle ABC. Side AB is tangent to the semicircle at point B, and we have here line segment AE is tangent or side AC is tangent to the semicircle at point E. Point E is the touching point between the tangent AC and the semicircle, and we want to find out the radius of this red semicircle. So first of all, I will present to you a new rule, rule number 1. We can also call it two tangents theorem. Rule number 1 or two tangents theorem. So, rule number 1 or two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So I will read rule number 1 again. Rule number 1 or two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1 or two tangents theorem? Actually, the meaning of rule number 1 is that if you have this circle and we also have an external point of this circle, here point P. Point P is an external point in relation to this blue circle because this point P is not located inside this blue circle nor on this blue circle, but is outside of this blue circle. Therefore it is defined as external point of this blue circle, and if from the external point P we will draw two tangents to this blue circle, so this will be the first tangent to the blue circle, and we will define the touching point between the tangent and the blue circle as point A, and we will also draw a second tangent to this blue circle, and we will define the touching point between the second tangent to the blue circle as point B. As you can see from the drawing, the length of this first tangent is actually PA, and the length of the second tangent is PB, and according to two tangent theorem, or rule number 1, whenever you draw two tangents to a circle, from an external point, then the length of those two tangents will be equal to each other. That is to say, PA equals to PB. Okay, so according to two tangents theorem, PA equals to PB. Okay. Again, if we have an external point of a circle and we will draw two tangents from the external point of the circle to the circle itself, then the length of those two tangents will be equal to each other. That is to say, PA will be equal to PB in this case. Okay? So this is the meaning of two tangents theorem, and we can actually implement the two tangents theorem in our drawing, because in our drawing we have point A. Point A is an external point of this red semicircle, because it is not located inside the circle nor on the circle, on the semicircle, but it is outside the semicircle. Therefore, it is defined as an external point of this red semicircle, and from point A we have two tangents to this red semicircle. The first tangent is AB, and the size or the length of tangent AB is 3 units according to what is given us in the question, and the second tangent from point A to the circle is tangent AE. So actually we have two tangents from the common external point, point A, to the circle. Therefore, the lengths of those two tangents will be equal to each other. That is to say, AB will be equal to AE according to two tangents theorem. But we know that AB equals to 3 units according to what is given us in the question. So from this equality, AB equals to AE equals to 3, we will derive that AE also equals to 3 units. AE, tangent AE equals to 3 units. So we can write here that AE is 3 units, equals to 3 units in its size, and we will define the center of this semicircle as point O. Actually, BO is the radius of this red semicircle because of the fact that line segment BO starts from the center of the semicircle, that is to say from point O, and ends at point B, that is the point on the circle itself. Therefore BO is the radius of this semicircle, so we'll define the radius of the semicircle as R. Therefore BO will be equal to R. And likewise OD, line segment OD, will be also the radius of this semicircle, because it starts from point O, that is the center of the semicircle, and ends at point D, that is a point on the semicircle itself. Therefore OD is the radius of this semicircle, so it equals to R. In the next step, we will join points E and O together by a straight line. Actually, line segment OE is the radius of this red semicircle because of the fact that line segment OE starts from the center of the semicircle and ends at point E, that is a point on the semicircle itself. Therefore, OE is the radius of this red semicircle, so it equals to R. And actually, tangent AC is tangent to the red circle at point E. Point E is the point of tangency. This point of tangency of tangent AC with the red circle. We will define line segment EC as X, that is to say line segment EC equals to X units in its size. And in the next step I will present to you a new rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I will read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have a circle, this circle, and the center of this circle is at this point, we will define the center of the circle as point O, and we also have tangents to this blue circle actually tangent AB, this tangent in the black color, tangent AB is tangent to this blue circle. At this point we define the touching point between tangent AB and the blue circle is point M. Point M is the point of tangency of tangent AB with the blue circle, point of tangency. Okay, point M is the point of tangency of tangent AB with this blue circle. Then we also have a radius that starts from point M, that starts from point O and ends at point M. So actually OM is the radius of this blue circle, and according to rule number 2, a tangent to a circle, that is to say tangent AB to the blue circle, is perpendicular to the radius drawn to its point of tangency. So actually this radius OM is drawn to the point of tangency, that is to say it is drawn, this radius OM is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency. Therefore the tangent AB is perpendicular to this radius, that is to say this angle equals to 90 degrees. The tangent is perpendicular to this radius, and this angle also equals to 90 degrees. As you can see, tangent AB is perpendicular to this radius from both sides of the radius. Both sides of the radius. Okay, so whenever you have a radius that is drawn to the point of tangency, like in this drawing, then the tangent will be perpendicular to the radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So that is the meaning of rule number 2. A tangent to a circle, tangent AB, is perpendicular to the radius drawn to its points of tangency. So this radius OM is drawn to the point of tangency, that is to say to point M. Therefore the tangent AB is perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. So we actually can implement rule number 2 in our drawing, because here we have tangent AC. Tangent AC is tangent to this semicircle at point E. Again, tangent AC is tangent to the red semicircle at point E. Point E is the point of tangency of tangent AC with this semicircle, red semicircle, and the radius, this radius OE, is drawn to the point of tangency, that is to say it is drawn to point E, that is the point of tangency. Therefore, according to rule number 2, the tangent AC is perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so actually angle OEC is a right angle, it equals to 90 degrees. Therefore triangle OEC is a right triangle. So here the green triangle OEC is a right triangle, so we will focus on the green right triangle, triangle OEC. So on the green right triangle OEC, according to the Pythagoras theorem, in triangle OEC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is OC, so the square of the hypotenuse is OC squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OE squared plus EC squared. I will repeat again. According to the Pythagoras theorem, in the right triangle OEC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. This is to say, OC square equals to OE square plus EC square. But what is the size or the length of OC? The length of OC, the length of side OC, you can see from the drawing that it equals to R plus 1. Again, OC equals to R plus 1. Therefore, OC square will be equal to R plus 1 square. Okay, OC square will be equal to R plus 1 square. And what is OE? OE is the radius of this semicircle, so it equals to R. And OE square will be equal to R square plus EC square. EC equals to X, so EC square will be equals to X square. So in total we got that R plus 1 square equals to R square plus X square, according to the Pythagoras theorem. Of course, here we will open the brackets of this expression and we will get that R plus 1 square equals to R square plus 1 plus 2R, according to the algebraic identity that A plus B square equals to A square plus B square plus 2 times AB. Okay, and it equals to R square plus X square. Okay, so here we have R square in both sides of equation number 1, so we will subtract R square from equation number 1, so R square will get cancelled. And what is left after we cancelled R square? What is left? It is actually 1 plus 2 times R equals to X square. Okay, according to equation number 1, 1 plus 2R equals to X square. Okay, so in the next step, we will focus on the right big triangle ABC, and we will also focus on the green right triangle OEC. Okay, so we will actually prove that those two triangles are similar to each other. So we will focus on triangle ABC, the right big triangle, triangle ABC, and the green small triangle, triangle OEC. I will repeat again that we will focus on the right big triangle, triangle ABC, and on the green right triangle, small triangle, triangle OEC. And we will prove that those two triangles are similar to each other. First of all, those two angles are equal to each other. They are both right angles. So actually angle ABC of triangle ABC, this angle, equals to angle OEC of triangle OEC, and both angles are right angles, that is to say they are equal to 90 degrees. Okay, I'll repeat again. Angle ABC of triangle ABC equals to angle OEC of triangle OCO, and they are both equals to 90 degrees. And we have also this angle is a common angle, that is to say it belongs to both triangles, it belongs to the big triangle, triangle ABC, and this angle also belongs to the green small triangle, triangle OEC. So we can write down that angle C equals to angle C is a common angle that belongs to both triangles. Okay, angle C equals to angle C is a common angle that belongs to both triangles, and we actually have those two angles are also equal to each other according to third angle theorem. So angle BAC, this angle, equals to angle EOC, this angle, according to third angle theorem. So I'll write it down. Angle BAC of triangle ABC, this angle, equals to angle EOC of the green triangle, according to third angle theorem. I'll repeat again. Angle BAC of triangle ABC equals to angle EOC of triangle EOC according to third angle theorem. Okay, so what is third angle theorem? Actually, third angle theorem or rule number 3 you can call it either third angle theorem or rule number 3 or both of them. Okay, so actually according to third angle theorem or rule number 3, if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. So I will read rule number 3 again, or the third angle theorem. According to the third angle theorem, if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. So what is the meaning of the third angle theorem, or rule number 3? The meaning of third angle theorem is that if you have two triangles, triangle ABC, this is triangle ABC, and we have also another triangle, triangle DEF. And we have two pairs of angles that congruent in both triangles. So the first pair of angles that congruent is here, this angle is alpha, and this angle in the other triangle also alpha. And the second pair of angles that congruent in both triangles is this angle is beta, and this angle is beta. So we have here two triangles that have two pair of angles that congruent. This is the first pair of angles that congruent, and this is the second pair of angles that congruent. And suppose that this angle is gamma and this angle is theta, then according to third angle theorem, or rule number 3, angle gamma equals to angle theta. I will repeat again. If we have two triangles that have two pairs of angles that congruent to each other, like in this drawing, this is the first pair of angles that congruent, and this is the second pair of angles that congruent, then the third pair of angles must be also congruent, that is to say, gamma must be equal to theta. Okay, so we will prove that this rule is true. Actually, we will prove that angle gamma equals to angle theta. Okay, actually, as you already know, the sum of the angles in any triangle equals to 180 degrees. That is to say, the sum of the angles in triangle ABC equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Okay. The sum of the angles in triangle ABC. Okay. In triangle ABC, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, the sum of its angles equals to 180 degrees. So in triangle DEF, the sum of its angles equals to 180 degrees. It means that alpha plus beta plus theta equals to 180 degrees. So actually, the second equation number 2 states that the sum of the angles in triangle DEF equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. So here we will subtract equation number 1 from equation number 2, and we will get equation number 3 that states that alpha minus alpha is 0, beta minus beta is 0, and gamma minus theta, gamma minus theta equals to 180 degrees minus 180 degrees is 0. So here we will add to equation number 3 theta, and we will get that angle gamma equals to angle theta. That is exactly what we wanted to prove. We wanted to prove that angle gamma equals to angle theta, and we proved indeed that angle gamma equals to angle theta. It means that we proved that the third angle theorem is true. That is to say, if we have two triangles that have two pairs of angles that's congruent, this is the first pair, this is the second pair of angles that's congruent, then the third pair of angles must be also congruent. That is to say, angle gamma equals to angle theta. Okay, so now we will repeat to our drawing. Actually, we proved that we actually proved that all three angles of the right triangle, triangle ABC, are congruent to all three angles of triangle EOC. Therefore, we actually proved that triangle ABC is similar to the green triangle, triangle EOC. Okay, we actually proved that triangle ABC is similar to the green triangle EOC according to angle similarity rule. So I will repeat again. we proved that triangle ABC is similar to triangle EOC according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that three angles of one triangle can relate to three angles of another triangle, you actually prove that those two triangles similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to triangle OEC, the green triangle, we will conclude that AB over AC in triangle ABC, AB over AC in triangle ABC equals to OE over OC in triangle OEC. I will repeat again. Because of the fact that triangle ABC is similar to triangle OEC, the following equality is true, that AB over AC equals to OE over OC. Okay, and what is the value of AB? Actually, the value of AB is 3 units. It is given us the question that AB equals to 3 units. So AB is 3. And what is the value of AC, the length of AC? From the drawing, we can see that AC equals to 3 plus x. Again, AC equals to 3 plus x. So we got that AB equals to 3, AC equals to 3 plus x, and it equals to OE. What is the length of OE? The length of OE is R, the radius of the semicircle. And what is the length of OC? The length of side OC of triangle EOC. It is actually R plus 1. Okay, so in total we got that 3 over 3 plus x equals to R over R plus 1. Here we will cross multiply equation number 2, and we will get that three times R plus 1 equals to R times 3 plus x. Okay, so here we will open the brackets of equation number 2, and we will get that three R plus 3 equals to 3R plus R times x. Okay. Here we have 3R on both sides of equation number 2, so we subtract 3R from equation number 2, so 3R will get cancelled. What is left after we cancel 3R? What is left? It is actually 3 equals to R times x. Here we will divide equation number 2 by x. First of all, why it is allowable to divide equation number 2 by x? maybe x is 0, and if x is 0, you are not allowed to divide by 0. You're never allowed to divide by 0. So how do we know that x is not 0? X is not 0 because EC, that is a side of the green triangle, equals to x. And the side of a triangle is always a positive number. It can never be 0. Therefore, it is allowed to divide the equation by x. So we will divide the equation number 2 by x, and we will get that r, the radius of the semicircle, equals to 3 over x. We found out, according to equation number 2, that the radius of the semicircle, r, equals to 3 over x. Okay? But according to equation number 1, we have already found out that 1 plus 2r equals to x squared. Okay? That is what we have already found according to equation number 1. So we actually can substitute r in equation number 1 in this equation by 3 over x, because r equals to 3 over x according to equation number 2. So we will do it now, and we will get that 1 plus 2 times r, and r is 3 over x, equals to x squared. So here 2 times 3 is 6. So in total we will get that 1 plus 6 over x equals to x squared. So 2 times 3 is 6, so we got that one plus 6 over x equals to x squared. Here we will multiply equation number 2 by x. It is allowable to multiply the equation by x because x can never be 0, as I have already said. So we multiply by x, and we will get that x plus 6 equals to x times x squared is x cubed. So we got this equality that x plus 6 equals to x cubed. Here we will subtract x from this equation number 2, and we will get that x cubed minus x equals to 6. So we will subtract 6 from equation number 2, and we will get that x cubed minus x minus 6 equals to 0. Okay, we got equation number 2 that states that x cubed minus x minus 6 equals to 0. Here we know that minus 2x squared plus 2x squared equals to 0, of course. So we will add minus 2x squared plus 2x squared to equation number 2. It is allowable to add 0 to any equation. So we actually add 0 to equation number 2, or instead of 0 we will add minus 2x squared plus 2x squared that equals to 0. Okay, so this operation, it is allowable because we can add 0 to any equation. So we will add minus 2x squared plus 2x squared to equation number 2, and we will get that x cubed minus 2x squared plus 2x squared minus x minus 6 equals to 0. Okay? And we actually know that minus x equals to minus 4x plus 3x. Okay? Minus x equals to minus 4x plus 3x. So we will substitute minus x in this equation number 2 by minus 4x plus 3x. Okay, so we will get that x cubed minus 2x squared plus 2x squared, and instead of minus x we will write down minus 4x plus 3x minus 6 equals to 0. Okay, so we got this equation number 2, this expression. Here we will divide equation number 2 to 3 parts, and we will take a common factor from each out of the 3 parts, out of every part. Okay, so first of all we will divide equation number 2 to 3 parts. The first part will be x cubed minus 2x squared. The second part will be 2x squared minus 4x, and the first part will be 3x minus 6. Okay, I will repeat again. We will divide equation number 2, this equation, to 3 parts, 1, 2, 3, and we will take out a common factor from each part. Okay, so part number 1 is actually x cubed minus 2x squared here. So we will take a common factor from x cubed minus 2x squared. The common factor that we will take out is x cubed. So we took out the common factor x squared from x cubed minus 2x squared. So what is left from this expression after we took out the common factor of x squared? What is left, it is actually x. And what is left from minus 2x squared after we took out the common factor of x squared? What is left, it is actually minus 2. Okay, so in total we found out that x cubed minus 2x squared equals to x squared times x minus 2. Then we will do the same process from the second expression in equation number 2. The second expression is 2x squared minus 4x. 2x squared minus 4x. Here we will take a common factor of 2x out of this expression. And again, we will take a common factor of 2x out of this expression. So here, what is left from this expression after we took 2x as a common factor, what is left, it is actually x, and what is left from minus 4x after we took out a common factor of 2x, what is left, it is actually minus 2. So in total, we will get that 2x squared minus 4x equals to 2x times x minus 2. We will do the same process for the third expression. The third expression is 3x minus 6. 3x minus 6. Here we will take a common factor of 3 out of this expression. So what is left from 3x after we took out a common factor of 3? What is left, it is actually x. And what is left from minus 6 after we took a common factor of 2? What is left, it is actually minus 2. Okay, so we have actually 3 expressions. We know that x cubed minus 2x squared equals to x squared times x minus 2. We know that 2x squared minus 4x equals to 2x times x minus 2, and 3x minus 6 equals to 3 times x minus 2. So we'll substitute those 3 expressions by what we found that those 3 expressions equal to. Okay? And we will get that equation number 1 is actually, so we'll substitute x cubed minus 2x squared by x squared times x minus 2. Then we will substitute 2x squared minus 4x by 2x times x minus 2. And finally we will substitute 3x minus 6 by 3 times x minus 2. All equals to 0. As you can see, the sum of those 3 expressions, 1, 2, 3 equals to 0. So here it is also equals to 0. So here we will take a common factor of x minus 2 out of this expression, out of this equation number 1. So x minus 2 is a common factor of this expression. So what is left from x squared times x minus 2 after we took a common factor of x minus 2? What is left, it is actually x squared. And what is left from this expression, 2x times x minus 2 after we took out a common factor of x minus 2? What is left, it is actually 2x. And finally, what is left from this expression after we took a common factor of x minus 2? What is left? It is actually 3, and all equals to 0. So we have here equation number 1 that states that x minus 2 times x squared plus 2x plus 3 equals to 0. So we got this expression. So here the solution to equation number 1, it will have 2 solutions that are possible. Either x minus 2 will be equal to 0, and if x minus 2 equals to 0, 0 times anything equals to 0, or either x squared plus 2x plus 3 will be equal to 0, and 0 times anything will be equal to 0. So we will write down those 2 possible solutions to equation number 1. So either the first solution is that x minus 2 equals to 0, and the second solution to this equation number 1 is that the quadratic equation x squared plus 2x plus 3 equals to 0. So we will focus on the second solution. The second solution is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This is the general formula for a quadratic equation when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula. Actually, x equals to minus b plus minus root of b squared minus 4 times a times c over 2a. Okay, this is the solution for the quadratic equation, this general quadratic equation. So in our specific quadratic equation, x squared plus 2x plus 3 equals to 0, here the coefficients are as follows. Here a is 1, equals to 1, b equals to 2, the coefficient b equals to 2, and the coefficient c equals to 3. So we will put the data inside this equation for x in order to find out the value of x in our specific quadratic equation. Okay, so we will get that x equals to minus b, b equals to 2, so minus b is minus 2, plus minus root of b squared, b is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a is 1, times c is 3, over 2a, a is 1, 2 times 1 is 2, so we got that this expression for x. So actually x equals to minus 2 plus minus root of 4 minus 4 times 1 is 4, and 4 times 3 is minus 12 over 2. So we got that x equals to minus 2 plus minus root of 4 minus 12 is minus 8 over 2. So here we have a negative number inside the root, and there is no root for a negative number. A negative number doesn't have a root. So therefore, the quadratic equation, this quadratic equation has no solution. Therefore, this option is not correct because it is no solution. As you can see, we don't have a root for minus 8, so we'll cancel this option, and we left only with the solution that x minus 2 equals to 0. So the solution, the only solution to this equation number 1 is that x minus 2 equals to 0, because the second solution is not correct because there is no solution for this quadratic equation. Okay, so we left only with the possibility that x minus 2 equals to 0. X minus 2 equals to 0. And if x minus 2 equals to 0, then x equals to 2. We found out that x equals to 2. And we have already found out, according to equation number 2, that r equals to 3 over x. So we found out that x equals to 2, so we can substitute x by 2. in the question number 2, and we will get that the radius of the semicircle r equals to 3 over x is 2, so it is 3 over 2 units, or in terms of, or you can also present it as 1.5 units. So we actually found out that the radius of this semicircle r equals to either 3 over 2 units or it equals to 1.5 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the radius of this semicircle we know that triangle ABC is a right triangle because angle ABC equals to 90 degrees, this angle equals to 90 degrees, side AB of triangle ABC equals to 3 units, side and the line segment DC equals to 1 unit, and we want to find out the radius of this semicircle. Actually, the semicircle is inscribed by triangle ABC, and we want to find out the radius of this semicircle. So actually, I presented to you rule number 1. According to rule number 1, or two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is actually that if we have this circle and we have external point P is an external point of this circle, and from point P we will draw two tangents to this circle. Tangent, this is the first tangent, this is the second tangent. Then the lengths of those two tangents will be equal to each other. That is to say PA equals to PB. So whenever you draw two tangents to a circle from an external point of this circle, then the length of those two tangents will be equal to each other. That is to say PA will be equal to PB. And we actually implemented rule number 1 or two tangents theorem in our drawing, because in our drawing we have the external point A, and from point A we have two tangents to this straight semicircle. The first tangent is tangent AB, that equals to size 3 units in its size, and the second tangent is tangent AE. So according to rule number 1 or two tangents theorem, whenever you have two tangents from an external point to a circle to that circle, then the length of those two tangents will be equal to each other. That is to say AE equals to AB. AB equals to AE according to rule number 1 or two tangents theorem, but we know that AB equals to 3 units. It is given us in the question. So from this equality we will derive that AE also equals to 3 units. Okay, then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its points of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have we have this circle, the center of this circle is at this point O, and we have tangent AB to this blue circle. Tangent AB is tangent to this blue circle at point M. Point M is the point of tangency of tangent AB with this blue circle. So according to rule number 2, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tangency. So we have this radius OM, it is drawn to the point of tangency, that is to say to point M, that is the point of tangency. Therefore the tangent AB is perpendicular to this radius that is drawn to the point of tangency. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so whenever you have a radius that is drawn to the point of tangency, then the tangent will be perpendicular to this radius. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so we can actually implement rule number 2 in our drawing. Because in our drawing we have tangent AC that is tangent to the semicircle at point E, and we have the radius OE that is drawn to the point of tangency. That is to say it is drawn to point E, that is the point of tangency. Therefore the tangent AC will be perpendicular to this radius. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. So because of the fact that angle OEC equals to 90 degrees, it is a right angle, therefore the green triangle is a right triangle. Triangle OEC is a right triangle. And we can implement the Pythagoras theorem in the right triangle, triangle OEC. In any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is OC, so the square of the hypotenuse is OC squared, and it equals to the sum of the squares of the perpendiculars, that is to say, it equals to OE squared plus EC squared. Okay, according to the Pythagoras theorem, OC squared equals to OE squared plus EC squared. But what is the value of OC? As you can see from the drawing, OC equals to R plus 1. So OC squared will be equals to R plus 1 squared. OC squared equals to R plus 1 squared. What is the value of OE? OE equals to R, so OE squared will be equal to R squared. And what is the value of EC? EC equals to X, so EC squared will be equal to X squared. Okay, EC squared equals to X squared. So in total we got that R plus 1 squared equals to R squared plus X squared. We open the brackets from this side of equation number 1, and we got that R plus 1 squared equals to R squared plus 1 plus 2R, and it equals to R squared plus X squared. Here we subtracted R squared from equation number 1, so R squared will get cancelled, and we got that 1 plus 2R equals to X squared. So according to equation number 1, 1 plus 2R equals to X squared. Then we focus on the right triangle, triangle ABC, on the green right triangle, triangle OEC. And we prove that those two right triangles are similar to each other. First of all, we know that those two angles are equal to each other, they are right angles. So actually angle ABC and triangle ABC equals to angle OEC and triangle OEC, and they are both equal to 90 degrees. We also know that this angle is a common angle, it belongs to both triangles, it belongs to the big triangle, triangle ABC, and it also belongs to the green triangle, triangle OEC. Therefore we can write down that angle C equals to angle C is a common angle that belongs to both triangles, and we actually proved that those two angles are equal to each other according to third angle theorem. Again, angle BAC in triangle ABC equals to angle EOC in triangle OEC according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. Okay, so what is the meaning of third angle theorem or rule number 3? The meaning of third angle theorem or rule number 3 is that if we have two triangles, triangle ABC and triangle DEF, and in those two triangles we have two pair of angles that are equal to each other. this is the first pair of angles that are equal to each other. They are both equal to alpha, and this is the second pair of angles that are equal to each other. Then the third pair of angles, so if this is the situation, then the third pair of angles must be also equal to each other. That is to say, angle gamma equals to angle theta, and we actually proved that angle gamma equals to angle theta. How? We proved that they are equal to each other according to the rule that the sum of the angles in any triangle equals to 180 degrees. Therefore, the sum of the angles in triangle ABC equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees in triangle ABC. And in triangle DEF, likewise, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. Okay, so we have two equations. We subtracted equation number 1 from equation number 2. Alpha minus alpha equals to 0. Beta minus beta equals to 0. And gamma minus theta equals to 180 degrees minus 180 degrees is 0. So we got that gamma minus theta equals to 0. We added theta to equation number 3. And we found out that angle gamma equals to angle theta. So we actually proved that angle gamma equals to angle theta, and that is actually the proof of third angle theorem. We actually proved that the third angle theorem is true. And the third angle theorem states that if we have two pair of angles that are equal to each other, this is the first pair of angles that are equal to each other, this is the second pair of angles that are equal to each other in two triangles, then the third pair of angles must be also equal to each other. That is to say, angle gamma equals to angle theta, and we actually proved that angle gamma equals to angle theta. Okay, so we proved that the third angle theorem is true. And we will return to our original drawing. So we actually proved that all three angles of triangle ABC are congruent to all three angles of the green triangle, triangle EOC. Therefore, we proved that triangle ABC is similar to triangle OEC according to angle similarity rule. Therefore, we can derive from the fact that triangle ABC is similar to triangle OEC that AB over AC equals to OE over OC. Again, AB over AC in triangle ABC equals to OE over OC in triangle OEC. Okay, that is because of the fact that both triangles, the triangles are similar to each other. And what is the value of AB? AB equals to 3 units, AC equals to 3 plus X, OE equals to R, and OC equals to R plus 1. So in total we got that 3 over 3 plus X equals to R over R plus 1. Here we cross multiply the equation number 2, and we got that 3 times R plus 1 equals to R times 3 plus X. Then we open the brackets in equation number 2, and we got that 3R plus 3 equals to 3R plus Rx. We subtracted 3R from equation number 2, and we got equation number 2 that states that 3 equals to Rx. We divided the equation number 2 by x, and we got that the radius of the semicircle equals to 3 over x. This is equation number 2, but according to equation number 1, 1 plus 2r equals to x squared. So we actually can substitute 2r in this equation number 1, by 3 over x, because r equals to 3 over x according to equation number 2. So we substituted r by 3 over x in this equation, and we got that 1 plus 2, r is 3 over x, equals to x squared. 2 times 3 is 6. So in total we got that 1 plus 6 over x equals to x squared. Here we multiplied equation number 2 by x, and we got that x plus 6 equals to x cubed. Then we subtracted x from equation number 2, and we got that x cubed minus x equals to 6. Then we subtracted 6 from equation number 2 and we got that x cubed minus x minus 6 equals to 0. We know that minus 2x squared plus 2x squared equals to 0, so we can add 0 to equation number 2. So we added this expression that equals to 0 to equation number 2, and we got that x cubed minus 2x squared plus 2x squared, that is 0, minus x minus 6 equals to 0. Then we substituted minus x by minus 4x plus 3x, because minus x equals to minus 4x plus 3x. So we substitute minus x by minus 4x plus 3x here, and we got this expression. Then we divided this expression to 3 parts, and we took a common factor from every part. Okay, the first part, it is actually, we took a common factor from each part. The first part, it is actually x cubed minus 2x squared, and we took a common factor of x squared from this expression. And what is inside the brackets? Inside the brackets we have x minus 2. So x cubed minus 2x squared equals to x squared minus times x minus 2. And then we took a common factor of this expression. The common factor is 2x, and inside the brackets we have x minus 2. Then we finally took a common factor from 3x minus 6. The common factor was 3, and inside the brackets we have x minus 2. Okay, and we substituted the 3 original expression by the values that we got from by taking the common factor. We substituted this expression by x squared times x minus 2. We substituted this expression by 2x times x minus 2, and we substituted 3x minus 6 by 3 times x minus 2, and we got this expression. Then we took a common factor of x minus 2 from this expression, and finally we got this expression that states that x minus 2 times x squared plus 2x plus 3 equals to 0. So here we have two solutions that are possible. The first solution to this equation number 1 is that x minus 2 equals to 0, and the second solution is that x squared plus 2x plus 3 equals to 0. And then we focused on the second solution to this equation number 1. The second solution is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. This is the special formula for x. And in our specific quadratic equation, the values of the coefficients a, b, and c, here actually a equals to 1, b equals to 2, and c equals to 3. So we put the data inside this equation in order to find out the value of x. So we got that x equals to minus b equals to 2, so minus b is minus 2, plus minus the square root of b squared. B is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a times c. 4 times a is 1, c is 3, so in total is 4 times 1 times 3 over 2. So here x equals to minus 2 plus minus the square root of 4 minus 4 times 3 is 12 over 2. So x equals to minus 2 plus minus 4 minus 12 is minus 8. But because of the fact that a negative number, minus 8, is a negative number, and a negative number doesn't have a root, therefore this we will not have a solution. We doesn't have a solution for this quadratic equation. Therefore, this possibility is not correct possibility, because there is no solution for this quadratic equation, and we left only with the solution that x minus 2 equals to 0. So if x minus 2 equals to 0, then x equals to 2, x equals to 2, but we have already found out that according to equation number 2, r equals to 3 over x. So we can substitute x by 2, because we have already found out that x equals to 2. So we substituted 2x by 2 in this equation number 2, and we got that the radius equals to either 3 over 2 units or it equals to 1.5 units. I will repeat again, the radius of this semicircle equals to either 3 over 2 units or it equals to 1.5 units. Okay, thank you very much.